So in the last video, we talked about static polymorphism, which achieved the results through something that is known as method overloading. So when we have the same method code, the way we have it here, but different parameters, which is what we have as well, we have different parameters, we are performing method overloading. And by method overloading, we were able to perform static polymorphism, or letting the same method have different behaviors. Now in this video, we'll be talking about dynamic polymorphism, which is basically a mechanism by which a call to an overridden function is resolved at a runtime, aka when your code is running on the machine. We achieve dynamic polymorphism through method overriding. So method overriding, as we already saw, just means that we have two or more methods with the same name and same signature, unlike in static polymorphism. However, what is different in this one is that those two methods with the same name and same signature will have different behaviors. So as you can see here, in the retail salesperson and car salesman, same method signature, right? Same method signature, but different implementation. So different implementation, right? But they're coming from the same base class. Okay, I agree. This all sounds very confusing. Let me go ahead and once again propose a hypothetical problem so that while we solve it, we can also understand what dynamic polymorphism is all about. Let's imagine that one of our clients calls us and says, "Hey man, remember that program you were writing with salespeople and developers? Okay, they have a new requirement. They just got this new database and the database contains all of the child classes of salesmen. For now, car salesman and retail salesperson. So this guy and this guy. There are over 1 million rows in that database. Just a bunch of car salesman and retail salesperson data as mentioned. Later on, they will be adding more child classes to the salesman base class. So keep that in mind, meaning these won't be two types forever. Very soon, they will be adding more and more. Your task is to load all of the items from the database, and then for each separate item, you need to show us how that salesman sells, regardless if it is a car salesman or a salesperson, or any other child class that we create from the salesman parent class. Now, what they want is a flexible software that will take all of the items from the database and print how they sell. And they don't want to be constantly changing the code. If they keep adding more types, they told me that after we release the software, they will be adding 50 types per day. So if they have to change the code that frequently, then they will just give this job to another contractor altogether. But if you can make it flexible so that they don't have to touch the code at all times, then they will give you the price you asked for, and also they will give you a bonus, which will be a 50% of the price you asked. So not a bad gig at all. Okay, so let's look at a diagram they sent us to even better understand the requirements. See here? They are going to have a database. In the database, they're going to have, this is just a few rows that I'm showing you, just an example. Also, I understand that the data in the message will be repetitive, but I just had to keep my table very simplistic. I don't want to denormalize it and everything else. Just for simplicity's sake, we're going to keep it like this. So this is just 3 rows, but they said there's millions of rows. So we have just a bunch of car salesmen and retail salesmen. We have a bunch of first names and last names, and just the messages are pretty much the same for car salesman and retail salesperson. So it just varies like that. But now from the database, we somehow have to load it into our application, and then we have to tell our application to basically show how each of these salesmen sells. Now, one quick thing. This is just a hypothetical database, and I won't be showing you how to connect with the database and load that stuff because that's just way too complex. We're just going to imagine that we have loaded stuff into our application, and that is coming from a database. But this is just so that you can see the problem within a more realistic context. But once again, I won't be doing any database connections or anything, just not to introduce more complexity to the course, at least for this section, because this is just about dynamic polymorphism. And once again, I just wanted to show you this problem within a more realistic application, so you see how this could be used in the real world. But I digress. So we have a database. Once again, we have to load that into an application, which this part we will just imagine that we have loaded it from a database into our application. And then we will have to find a way to flexibly show the end user how each of these salesmen sells. And we have to do it in a way that even if they add more types here, we don't have to touch the code in our application, okay? The first thing that comes to mind is that we will not be instantiating all of the classes line by line and then calling the sell method on them. We can try that, but you already know the problem with that. Let's give it a try. So I will go here and I will actually remove this. And let's go ahead and write our code. So here I have two car salesmen and one retail salesperson. So I will say car salesman, and I will say car salesman just for simplicity's sake. Once again, I'm just going to name this car salesman 1 and new car salesman. I'll put the names in just a bit. Just want to get this part going. And then we will have a retail salesperson. So retail salesperson. Okay. And that will be that. And here we go. Now for each of these, after I put the names, we're going to have to call sell method on them, right? To see how each of these salesmen sells. Now that's what we're going to do here. That's cool. And also here, I think the spacing is messed up, that's why. Okay. And do the same for this guy, do the same for this guy. Okay, so this is 2. That's what I meant. And here we also are going to have sell. Okay. Now we can also pop in the names that we have from our sample. I will go ahead and quickly do that as well. So I'll actually copy it from here. 1. All right, that's good. And then we have 2. All right. And last one, actually, this one was for our retail salesperson, if I'm not mistaken. So just this part. And I just want to double check that. Nope, that's for our car salesman, actually. Okay, so that's fine. That was my mistake. I'll just copy this, bring it back. So we have already all the information. And I'm just going to grab this guy and pop it right in here. Okay, so now we have it all. Now, there are a lot of problems with this. Let's say magically we were able to write 1,000,000 of these statements, which is already ridiculous. But if they add more rows, not even types, we will have to open our program and add another line for just that row in the database. This is a horrible solution. One thing which comes to mind is a list. Why not load these in a list? So that's a bit of a better solution. So we can go ahead and do that. The question though is, since we have different types, how can we put them in one list? One way we can do that is by using an object type. Basically, you can think of an object as the ultimate base class for all data types in C#. So you know how our salesman is a base class? So this guy, right, is a base class for retail salesperson and car salesman. Well, object is a base class for everything in C#. So we can take advantage of that and say, hey, our list can take anything including salesman child classes or any other type. It's all inclusive. So for example, this is a car salesman and this is a retail salesperson. But I can say, I can just put salesman in both places and it will just be fine. Why? Because these two classes are child classes of this base class. Whether it's a car salesman or retail salesperson, it plugs right into the salesman. But what I'm saying is we can go a few levels higher and just say object, right? So just say object and that will work just fine because object is a base class for everything else. The only problem is that the object doesn't know about the sell method, and we will take care of that in just a minute. But let's bring this back. Okay. Now let's make a list as I suggested. And let's say this is a list of objects. And we will say salesman. So salesman equals new list of objects. And we're just going to have to import the system collections generic. That's fine. And then what we're going to do is we're actually going to put the declarations within our list. So right here, 1, 2, 3. All right. And take out our line by line instantiation. Now here's the thing. This is the part where we need to kind of wire up our imagination. Just imagine that this part is being loaded from the database. So some program that we wrote just grabs stuff from the database and puts them right in here. It converts the database information into our types that we have in our application and puts them right into our list. So this is basically what we have given. So even if they put more rows, more types, anything else, we don't have to touch this. That will automatically come into our list and be put right here for us. Now what we need to do is we need to write a method that will flexibly take these types and print the way they sell. So it's have to take a salesman and tell us how that salesman sells. Now this looks much better, but we're not calling the develop method. Let's loop around our list and call the develop method on each class. But wait, since we put classes into a list that accept objects, remember that problem? How do we then convert them back into our types that we put them in initially? Because we can't really use the sell method, and I'll show you why. So if we say for each, and then we just say var item in salesman, this item doesn't know anything about sell. All right? It doesn't know what sell is because we're basically going all the levels up to object and putting these into our object. And the object points to our child classes. But the parent class doesn't have that method on it. If we go a few levels down to salesman, it will know what sell method is. But at the highest level, at an object, we don't know what that sell method is. So what we need to do to get around that is use casting. Casting is just a process of going from one type to another. In this case, we're going from one object to salesman child class. So let's make a method called show me how to sell. So I will just basically create another method and say static void show me how to sell. And that method will take in an object. And we'll say it's a salesman. All right. And then we'll just say each item will be passed into the show me how to sell method. Okay. And then we'll take care of the rest inside the method. So once we get the object, we then have to determine its type. And we can do this by the isReserved keyword. So we can say if the salesman, which is the generic object being passed in, is car salesman, then just create car salesman variable, okay, with the car salesman type, and say, this is how you do casting, by the way. You put parentheses, and you put the type that you want to convert to from the type that you have. So in this case, salesman. Okay. And this is how you are converting from whatever object, in this case object, the most generic object, back to what it was. So as you can see, it's just a two-way conversion. We're going from a concrete class to a very generic class, and then we're going from a generic class to a concrete class through casting. That's all we're doing, from one to the other. Now, once we have converted it into car salesman, we then say, oh, okay, cool. I know how to call the sell method on that. And we just say sell, okay? And then else, since we only have two types, we can just say else. and say, all right, well, otherwise it's just gonna have to be retail salesperson, right? So we just do this, just change the name of the variable for readability's sake, and here we go. As you can see, we're checking to see which type of salesman it is so that we can appropriately convert our object into that type of salesman and then call that sell method on it. Now let's run the program. I'm gonna pop that in here and run the code. So here we go. We have a list. I'm going to breakpoint right here. And each time we go, first item is a car salesman. We already know that. Step into, it's going to say, what is this salesman you passed me? Is it a car salesman? Yes, it is. Now it's going to convert it into car salesman and call sell. See, I would recommend you to buy this car. So I'm actually going to bring it right up there. There we go. So we can see it easy. And then it's gonna go to the next one. Okay. Goes to the next one, says, what is the next one on the list? Is it still car salesman? Yes, it is. Call sell method on it. Now, next one. What is it? Retail salesperson, right? Now it's going to go and say, is it car salesman? No. Okay, retail salesperson. Perfect. See? I would recommend you to buy this pen. Nice. With the first name and last name also. Now, that's great. Now, this works, but if we add more types, we would definitely have to mess with our code, meaning we won't satisfy the business requirement. Let's try it. I will add another type. So I will basically create a new file called insurance broker. And I will say insurance broker CS. And that's that. Then I will copy the code from here. Go to insurance broker. Rename. Copy that. Is it self-developing? Well, we're not gonna give it self-developing properties just for the sake of it. Keep it simple. And, you know, changing the constructor name. Cool. Hi, my name is whatever the name we give it. I recommend you to buy this insurance. So, okay, so that's that. And then develop class, we don't need that, so we're gonna take that out. Okay, so that's it. Now, if we come back to this, right? Now let's say they added something in the database and we automatically loaded it here. We say new insurance broker, all right? And we just say, let's say that's my name and that. Now, if we run this, you'll see what happens. I'm actually gonna take this out so we can speed it up a bit. You'll see that it runs for the first one, it runs for the second one, it runs for the third one, but the fourth one, it's not gonna know, it's gonna break. It's gonna say unable to cast object of type insurance broker to type retail salesperson. This just means that we have to change our code. We have to go ahead and we have to change our code. We have to add another condition. And we have to say something like this. We have to say, you know, else if basically the salesman is a type of retail salesperson, then do this. And otherwise, you know, take care of the new case, new type that is insurance broker, right? And we can change this as well. And this will work. But as you saw, you know, if they start adding 50 more types, they have to add 50 more types here. So you can see that this can get really, really large really quickly. And that's definitely not maintainable, definitely not scalable. In the next video, we'll look for a solution on how to get out of this problem.